talk about what's coming up. We have 2 more tests left in this 9 weeks. We will take a test on 3.1 to 3.4. We will then take another test from 3.5 to 3.6. So that's 2 more tests. You will have an exam review that you will be doing over the break. I will be giving that. It is 100 points. It will be something that I actually go through and look at it. So I need you to make sure you take a nice picture of it and upload it into a Word document or as a PDF, because I will look to make sure that you complete every problem. With work, it will not be, if they require work, I will need to see the work. If you just give me a bunch of answers, you will get a bad grade on this. The exam review is graded for not necessarily correctness, but effort, where I actually look a lot harder at it than I do your homework. And it's worth 100 points, so it's basically worth a test grade. So you have 3.1 to 3.4 test, 3.5 to 3.6 test, the exam review. So those are basically 3 tests. And then you also have 1 makeup test that you can redo. So you have 4 major grades to change this 9 weeks around. So you could definitely go from something like an F to an A very easily. So it's all just according to how hard you want to work. So that's the coming up. We only have what, like 4 weeks left of the 9 weeks. We have 2 before we go on break. We have 1 when we get back, and then we have the exam week, and then that is finals for the first semester. All right, so your homework. Robert, because you were asking me questions, I'm going to try to make sure you understand. So someone saw that this is a pattern. They said, hey, if you have some number to the third power and you have some other number to the third power, you can factor it in a fast way. And the pattern was a minus b, a squared plus ab plus b squared. But in order to have this pattern, Robert, you have to have something to the third power, something else to the third power. So like if I wrote x cubed minus y cubed, it's really easy. Why? Because right here I can see that x is my a, y is my b. So everywhere I have an a, I put an x. Everywhere I have a b, I put a y. So it would turn into like x minus y, x squared plus xy plus y squared, right? It's very simple. Why? Because it's already to the third power. I just label my a's and my b's and plug them in those areas. Does that make sense, Robert?
Yeah, that makes sense.
Now, when I have this one, why is this one a little more of a pain in the butt?
They're not cubed. Both of them aren't cubed.
Right. So you weren't here for me for all year, but what I try to teach kids is in mathematics, Robert, if you gave me $1, I could give you 4 quarters back, correct?
That's correct.
Do they look the same?
No.
Does it have the same value?
Yes.
I get that concept with math. That's what I do all day long. I change the way things look. So I'm about to change the way this 8x to the 6th power looks, but I'm not going to change its value. In fact, what do I want it written as? I want it written as something to the third power. Does that make sense now?
Yeah, how would we get there?
Let's talk about it. How do I change this?
Didn't we do this? And like, we somehow ended with a parentheses, like number in parentheses, and then outside the parentheses was an exponent.
Yeah, but remember, it's got to be the same number. How can you rewrite 8 using the third?
Do we just use 8? Oh, 2 times 2 times 2.
So
2 to the third.
2 to the third. Now here's another issue. This is x to the what?
6.
And I need it as x to the third, but it still has to be equivalent to x to the 6th. So how could I rewrite it?
So would x to the third be inside the parentheses?
No. I want that x, and I need it to the third power, but the total has to equal 6. Robert, what if I put x to the second to the third power? What do you do with these exponents?
You add them.
No, you don't.
Oh no, because one's like in parentheses, so you multiply them to get
Yeah.
x.
And so what is this actually equivalent to?
X to the 6th.
So instead of x to 6, do you see how right here I can write this? What is this replacing?
What the? Oh, that's B.
No, what is this replacing from up here?
That's A. It's
No.
replaced AX.
It's replacing the 8. What is this replacing?
The X.
The x to the 6, yes?
Yeah.
This is the same as that. This is the same as that. Now, how can I rewrite this? Do you see how they're both to the third power now?
Yeah.
So I can write it as 2x to the second to the third power. Now I have my a minus y to the third. Now I have my b. So when I try to follow that pattern, which was a minus b, a squared plus ab plus b squared, I have the numbers to plug in. What's going to plug in for a? The 2x to the second minus what's plugging in for b? Y. Robert, does that make sense now?
Yeah, that makes sense.
You sure?
Yeah. Because we have to make it cubed before we can do anything else.
Yes,
Then
because
follow
if
the
it's
formula.
before we can get it cubed, if it's not cubed, I don't know what a and b are, so I can't follow this pattern. I can't follow this pattern until I get something cubed, because that's going to be my a and that's going to be my b. And then I just square this, right? 2x squared squared is 4x to the fourth plus this times this is 2x squared y, and this squared is just y squared.
Yeah, that makes a lot more sense.
So like this one, m9 minus y cubed. They want me to factor this. Well, whoops, sorry, I messed that up. m9 plus 27 into the 6. Well, I need to either make this sum of cubes, difference of squares, something. So I look at this and I start looking at these numbers and I go, okay, I can make that something to the third. I can make that something to the third, and I can make that. So I can make this a sum of cubes. How can we rewrite m to the 9th to make it to the third power? M to the what?
Would it be 3? M to the third.
To the what?
To the third.
And then boom, there's my a. Plus, how do I rewrite 27? 3 to the third. 3 times 3 times 3 is 27. And then n to the what?
Second.
To the
Third.
So then this would be m to the third. Just rewrite it. This is my a. Plus, how can I rewrite this? I can rewrite that as 3 n squared to the third. Notice this is to the third, this is to the third, so I can just put them both together in here because I can distribute that 3. That's what that does. So now I have my b. And now I can follow my pattern for this one, which was a plus b, a squared minus ab plus b squared. Can you try that on your own now?
Yeah, I'd like to try it on my own.
Anyone else have questions?
I do.
Yes.
Could you go over question 28 in our homework?
So this one is supposed to be recognized as difference of squares. And when I recognize difference of squares, I realize that the middle term is going to cancel out. So all I have to do is square this one, and subtract them.
Oh, okay. Thank you.
Because it's difference of squares, I realize that this is the same thing as this one. The middle term is going to cancel out because Ashton, what is x times negative 9?
Negative 9x.
What is this times this?
9x.
Positive 9x. These cancel out, so I'm supposed to recognize that's a difference of squares, and I can just do it quickly. All this is to recognize for speed.
Yeah.
Because technically, you could still distribute it out. It's just going to take longer.
Mm-hmm. All right, thank you.
Mm-hmm. Questions?
Mr. Martin,
Yes?
when is our next test going to be?
I don't know. I didn't figure that out yet, but it will be soon because we are finishing 3-3 today. So we'll finish 3-4. It'll be either the end of this week or beginning of next.
Okay.
The 3-5, 3-6 test will be shortly when we get back from the break.
Okay. And will we have like a review for it?
Yeah, I try to make reviews for everyone. I can't
Okay.
always promise, but I do try to make those normally.
Okay. Thank you.
Mm-hmm. All right, so today's assignment, today's new stuff, we're going to learn about this man named Pascal. And what he did was he helped us so that we don't have to do this. If I asked you to expand that out, can someone please explain what you would have to do and why that would take so long?
Write out x plus 3y 5 times.
And then what do I have to do?
Multiply each individual value by the ones in the other boxes or parentheses every time.
But I only attack 2 at a time, correct? Remember me telling you that?
Yeah, and then you have to move down.
So we would distribute this, we would get an answer, and then we'd still have these 3 behind it. With me? We'd have to like multiply it out, combine like terms, and then we would have to distribute this one out. We get an answer. We'd have to combine like terms in here, and then we'd have to do this. Do you guys see why it would take so long to do that? Hello?
Yes.
Yes.
That makes sense why that would be miserable.
Yeah.
So Pascal came up with a much shorter way of doing that, but it only works for a binomial. Binomial is 2, so this is a binomial. And when we are expanding it out, we're taking it from factored form and we're making it in that long, 20x to the 5th, whatever it is, okay? So instead of having to do the whole distributing, combining like terms thing, he came up with a much faster way. So here is his triangle. I'm going to first explain the triangle to you, and then I'm going to explain how to use the triangle. First, you just understand the way the triangle is formed, and then we'll show you how to use it. Anyone think they see the pattern here? There's a pattern. Someone try to find it. I'll give you a hint. Look at the row before it.
The outside numbers always go up by.
Yeah, the outside number is always what?
If you add the ones together, if you add the ones that are together, they make the number that's below them.
So like once you get past here, right, you always start with a 1. What's 1 plus 1?
2.
2.
See where that number was made from? And then 1, right? What do I start with for my next row? Always a 1.
1.
What's 1 plus 2?
3.
What's 1 plus 2?
3.
And 1 here, yes? Are you guys starting to see that pattern?
Yeah.
Okay, I'm gonna call on you. Noah. Noah Brown, what do I start with first for my next row?
Oh, I see it. Sorry.
You're all right.
Yeah,
You got it, Anna. Annabelle, I'll call you in a minute. What do you start with, Noah?
I was gonna say the 3, or would it be?
Mm-mm.
Are you asking the third row or the?
Nope, this next row down here. What do we always start with?
1.
There we go. Sierra, what would be my next number next to the 1?
Wait, I thought it was my turn next.
I'll get you in a minute. I'll get you next one.
Say it again.
What would be the next number that goes right here?
6.
Yep. Annabelle, what would be the next one?
I don't know this one. You gave me the hard one. It would
Mm-mm.
be 13,
No.
14,
Hold on. Look.
15.
There we go, because we had the 5 and the 10.
And then it'd be 20.
Yep. Tucker, what would be my next number? Tucker.
Can I answer it?
Yeah, I'm doing this also to figure out who's here and who's not here. So I'm kicking people out if I ask you questions and you don't respond. You need to be ready to respond quick. It's a click of a button. Go ahead, Tay.
15.
Good. Dominic, what would be the next number?
6.
Very good. Daniel, what would be my last number?
A 1.
Does everybody understand how the triangle is made? Because you don't have to memorize it. If you understand the concept, all you have to do is remember to start like this, and then the rest of the triangle is made. Like you could make the next one, right? 1, 7. Some of you might hurt your brain with the adding, but you can use a calculator. Does that make sense?
That makes sense.
That makes sense.
Yep.
Okay, so that's the triangle. Now, what happens is, in a minute, I'm going to show you more, but for right now, if I'm in the 0 power, actually, I'm going to write the numbers. Tucker. So this is 0. This is 1. This is 2. This is 3. Does everybody understand so far? This is the 4th. So if I told you that I was dealing with x minus 3 to the 5th, I would be dealing with this row right here. Now, I haven't exactly told you how to use it yet, but that's what row I would be using. Hey, Tucker.
Yeah.
I called on you, you didn't answer, so I kicked you out. That's how it's gonna work, remember? So make sure you're by your computer so I can ask, if I ask questions, you're ready to answer.
Okay.
Does everybody understand how to know what row you are dealing with?
Yes.
Be careful, why is it kind of tricky? It starts with row what?
0. Row run is rows. It's 0.
Yeah, it starts with 0.
Well, because 1 is 0, technically.
The 0 power, yes. Anything to the 0 power is 1, yes.
Yeah.
So this man, thank God for him, saw this pattern and made expanding something like this something we can actually do. So we can actually expand that now without having to pull our hair out because of this pattern that he saw. So the first thing I'm going to do is I'm going to recognize what power am I dealing with? Eric, what power am I dealing with?
4.
4.
So remember, this is 0, 1, 2, 3. So this is the row I'm going to be using for this problem. So I'm actually going to write those numbers down. 1, 4, 6, 4, and 1. That's how I'm going to start this out. Does everybody understand that so far?
Yeah.
Next, I'm going to take this number and this number. So I'm going to do this x to this power. And then this one to the 0. Notice when I add this power and this power, it gets me back to the total that was right here. I know I did this right because 4 plus 0 is 4. Now watch what I do with my 4. Right behind it, I'm going to do x to the 3rd. Notice 1 less than this one. So what do you think that means I'm going to do -3 to the power of?
1.
1, because again, together, 3 plus 1 equals my 4 that I had up here. What do you think I'm going to do next behind the 6? It's going to be x to the
Second.
Power.
perfect. And what behind it? Isabella?
-3.
Yep, no, you're good, Daniel. Go ahead. I'll call her next.
-3 to the first power. Oh, no, second.
Second power. Good, good. Because again, together they have to add up to 4. Notice the first one is always going down by 1. The second one is always going up by 1. So, Isabella,
Yes.
what would be my next thing? Behind the 4, what would I write?
Would it be 2? Oh, x.
Okay, x to the what power?
Second.
Well, look, we did 4, 3, 2. So what do you think is going to go next?
1.
Yep, and then what's going to go behind it?
A -3.
To the what power?
1. I'm still a bit confused about this.
I know, that's why I'm trying, that's why we're talking this out, because when you talk it out, then it makes it helps your brain, I promise. That's why I'm calling on you guys.
Yeah.
What is 3 and 1 together?
4.
What is 4 and 0 together?
4.
What is 2 and 2 together?
4.
So what did that mean? This power has to be back here.
3.
There it is.
Yeah.
Try the last one. What is the x going to be to the power of?
-3.
No. What is x going to be to the power of? Keep going down. 4, 3, 2, 1. What would x be to the power of? 0. What does that mean negative 3 is to the power of?
4?
Yep.
Yeah.
Does everybody understand how I got those? Remember, this is the first one that I did. This is the second one. And I literally went 4, 3, 2, 1, 0. And the other one did the opposite. It went 0, 1, 2, 3, 4. Again, always adding to the total power that I had at the beginning. Please ask me questions before I move on.
Are we gonna be able to like try another one just in case? Because I'm not sure. I kind of get it, but I'm not 100% sure.
Yes, but Kelly, do you understand? I look at this power. That tells me this row. I wrote these numbers down and gave some space because I'm going to write stuff behind it. This is the first thing I write behind it, always to this power. And then that means this one has to be to the 0. And then I keep going down the same. I'd write the same exact thing. Always going down one power with the x, always going one up with the other one.
And so it just has to add up to whatever the original power is, right?
Right. So if you always start this
Okay.
one with 4, or let's say that was 5, you'd start this one with 5. That means this is going to start with what?
0.
Right? Always 0, right? And then this one is always going to be 1 less than
Yeah.
whatever is here. And this one has to be 1 more because together they have to, when I take 1 away from here, I have to give this 1. So together they add up to that total right there.
Okay, yeah, that makes sense.
Right? Now, the rest of this problem is just simplifying the crap that I already have. Here's what I mean. What's negative 3 to the 0 power?
One.
Anything to the 0 power is 1. What is 1 times 1?
1.
And then 1 times x to the 4th is just x to the 4th. All this turned into was the x to the 4th. Does that make sense? Negative 3 to the
Wait,
first.
can you do that again?
What part, Nina?
I just missed the very, very end of it, like where you got x to the 4th.
Well, do you understand that negative 3 to anything to 0 power is 1?
Yeah.
And then I can multiply the numbers together, right? This is really just 1 times x to the 4th times 1. That's what all this garbage really is. Because
Oh, okay.
negative 3
I
to
see
the 0 is 1, so that's 1. And then I said 1 times 1 is 1, and then 1 times x to the 4th is just x to the 4th.
Okay, got it.
And I'm going to do that same thing through these other ones. So what's the second term? Well, it's a 4, it's an x to the 3rd, and it's timesing by a negative 3 to the first power. Well, first off, what's negative 3 to the first? Negative 3. What's negative 3 times 4? Because those can actually multiply together. That's negative 12. And then negative 12 x to the 3rd. Moving on to the third term right here. That really is 6 times x to the 2nd. And this is negative 3 to the 2nd too. Well, this turns into a 9. 9 times 6 is 54. And then 54 x to the 2nd. The fourth term is 4 times x to the first times negative 3 to the 3rd. This right here turns into a negative 27. Be careful, that's negative 3 times negative 3, which is positive 9, times the negative 3 is a negative 27. 27 times 4 is a negative 108. X. And then finally, we have 1 times x to the 0 times -3 to the 4th. Anything to the 0 power is 1. 1 times 1 is 1. 1 times, and then this turns into an 81. 1 times 81 is a plus 81. And that is my final answer for that one. That is this completely broken out, unfactored, distributed. But it didn't take me 20 years to do it. Does that make sense?
Yeah.
Yeah.
All right, I'm going to go a little faster on this next one. 1, 1, 1, 1, 2, 1, 1, 3, 1, 6. First off, I established that it's to the 5th power. Therefore, I'm in the 5th, this one right here. That's considered the 5th row. Because remember, we start with 0. So 0, 1, 2, 3, 4, 5. Also, if you notice, this row, the second number in matches up with what power I'm dealing with. So I know I'm going to write a 1, a 5, a 10, a 10, a 5, and a 1. The first thing I'm going to start with is this is my first one, s to the 2nd. 3 is my second part. So I'm going to write s to the 2nd and then a 3. I'm going to write s to the 2nd and then a 3. And s to the 2nd and then a 3. Every one of these is getting an s to the 2nd and a 3. That's an s, by the way. Now, what power am I going to raise the s to the 2nd on? Well, in this one, since it's the first one, I'm going to raise it to a 5 because I always raise it to this power right here, and that means it gets 0 3s. I'm going to raise the s to the 2nd to the 4th power here, and then that means I'm going to raise the 3rd to the 1st power. S to the 2nd is going to be the 3rd, which means this one's going to be the 2nd. S to the 2nd is going to be the 2nd, so this is going to now be the 3rd. S to the 2nd and this one is going to be the 1st, so that means the 4th for this one, 0 for this one, and 1 for that. Did that make sense? Hello?
Wait, the last one it's 0 and 1?
Oh, 0 and 5, sorry. Nope. Thank you. Does that make more sense now?
Yes.
So basically, it just goes in order each time, like 5, 4, 3, 2, 1, and
Yeah.
0. Oh, okay.
Yeah. But you have to remember what the first thing is. So that's why, did you notice I wrote all the first one and the second one? Like I just wrote an S to the 2nd and a 3rd. I just gave each one of them one of those. And then I filled in the powers.
Yeah.
Now what I'm going to do next is simplify this. So this is where it gets a little tricky. So that's a 1 times S to the 2nd to the 5th times 3 to the 0. Okay, let's deal with the first things. What is 3 to the 0? Come on. What's 3 to 0?
1.
And then 1 times 1 is 1. And then this turns into S to the 10th. When we have power to a power, we multiply those. So this first term is S to the 10th. Dealing with my second term, this is 5. S to the 2nd to the 4th, 3. I know that's a weird 3 to the 1st. 3 to the 1st is 3. 3 times 5 is 15. So it's a plus 15. And then S to the 8th. This is 3 to the second is 9. 9 times 10 is 90. S to the second to the third is S to the sixth. 3 times 3 times 3 times 3 is 27. 27 times 10 is 270. S squared or to the second is S to the fourth. 3 to the fourth power is 81. 81 times 5 is going to be 405. So that's the 81 times the 5, there's the 405. And then S to the second to the first is just S to the second. That's a 5. Finally, this is a 1. Anything to the first power is 1. 1 times 1 is 1. And then 3 to the fifth is 243. So there it is, completely expanded out. And it didn't take me 20 minutes, it took me 5. Kelly, did that help out?
Yeah.
What's your
Yeah.
question? The only new part is the triangle right here and understanding the 5, 4, 3, 2, 1. The simplifying of this term should not be new. Simplifying of this term should not be new. We should be able to do that. This is 5 S to the second to the fourth times 3 to the first. You should know order of operations. 3 to the first is 1. Then I can multiply the 3 times the 5 because it's commutative, and I can multiply numbers times numbers, which is 15. And then power to a power, you multiply those. So that's where the 15 S to the 8 came from. None of this simplifying this part should be new. But you have like, I don't know, 6 questions for you to practice that tonight. To make sure you understand that. That's called the binomial theorem. It's how to expand out a binomial without having to do it fully out. Any specific questions?